For question number 3 of our final exam review, I have the blood alcohol level H hours after consumption of 2 ounces of pure ethanol is given by C of H is equal to 55 hundredths times H divided by H cubed minus H squared plus 5. We want the blood alcohol level as H approaches infinity. So the limit as H approaches infinity of 55 hundredths times H divided by H cubed minus H squared plus 5. We are going to divide the numerator and denominator by the highest power of H in the denominator, which in this case is H cubed. So we get 55 hundredths divided by H squared divided by 1 minus 1 over H plus 5 over H cubed. So when we let these approach infinity, the numerator tends towards 0. And then for the denominator, we have 1 that just stays at 1. Minus 1 over H approaches 0. Plus 5 over H cubed also approaches 0. So 0 divided by 1, this would give us a value of 0. So this would be interpreted as the number after many hours, the blood alcohol level approaches 0. For the fourth question, Mueller's formula for calculating the total amount of rest in minutes required after performing a particular type of work activity for 30 minutes is given by the formula R of W is equal to 30 times W minus 4 divided by W minus 1.5, where W is the work expended in kilocalories per minute. A bicyclist expends 8 kilocalories per minute as she cycles home from work. We want to find R prime of W for the cyclist, so R prime of 8 in this case. So applying the quotient rule, R prime of W would be 30 times W minus 1.5 minus 30 times W minus 4 times 1, all divided by W minus 1.5 squared. This cancels to be 75 divided by W minus 1.5 squared. And if we put 8 into this derivative, we get a value of 1.78, rounding to 2 decimal places. So after expending eight kilocalories per minute, the bicyclist's rate of change of work is 1.78 square minutes per kilocalorie based on this problem. Let me know if you have any questions or concerns. Thank you.